Welcome back to Linux Fundamentals, Module 008, User Management and File Permissions. This is one of the most important modules in the entire course, and probably the one that will come up often in your career. In Module 007, you learn to edit files directly on a server with Nano and VI, monitor processes with PS and top, and read system logs. In this module, we build a security layer on top of all of that. Three big areas. Part 1, who can use the system? Users, groups, and the files that store them. Part 2, what they can do. Read, write, and execute permissions. chmod and chown commands. Part 3, the Linux Essentials exam favorite topics. Symbolic links, hard links, and the sticky bit. Every cloud server you will ever manage needs users created, groups assigned, and permissions controlled. Get this right and you understand the foundation of Linux security. Get it wrong and your production server is wide open. Go ahead and access your EC2 instance now and run the commands along. A quick recap from Module 7 before we dive in. 5 things you should already own from the last module. 1. Nano with an argument of a file name opens a new file or opens an existing file. Type and edit and then use the Ctrl+O to save. Use Ctrl+X to exit. No modes. 2. VI with an argument of a file name opens a file in command mode, the default mode. Press I to insert. Type or edit file and then use escape to move back to command mode. Then :W cure to save and quit. Emergency exit is :cure with an exclamation mark. Every cloud engineer has used it. PS with the options AUX shows all running processes. Top is the live monitor. Kill PID sends a signal to terminate, the polite request to kill or stop a process. Kill -9 with the PID sends a signal to kill, the way to forcefully kill the process. 3-S shows RAM usage, and DF-S shows this usage. System logs live in /var/log, and off.log for logins. 6log for general events. Journal CTL with the options X and E shows recent system D errors. Take note that the E in the options of journal CTL is meant for the most recent errors. The X in here is meant for extra notes that are attached to those errors. Today, we shift from working on the server to controlling who can work on it. You have seen the permissions column in ls-l output since module 004. Today, you understand every character and change every one of them. Here are the objectives for this module. These map directly to the Linux Essential exam topics. By the end of this module, you will explain the 3 Linux user types. You will read the /etc/passwd file and understand its 7 fields. You know why /etc/shadow file exists and who can read it, and understand why /etc/skel directory does for new users. You will create users with useradd and adduser commands, set password with passwd command, and manage groups with groupadd and usermod commands. You'll be able to decode the permissions column in ls-l output. Change permissions with the command chmod using both symbolic and numeric notation. And then learn how to transfer ownership with chown command. You will create symbolic links with the command ln with the S option and hard links with the ln command without any option. You will understand exactly what happens to the symbolic or hard link when the original file is deleted. You will also understand the sticky bit, what the D in the permissions column means, why /term has it, how to set it. The objectives that cover the /etc/shadow file, symbolic and hard links, and the sticky bit are all relevant for the LPR exams as the certification tests them directly. Part 1, users and groups. We start with who. Linux is multi-user from the ground up. Every file has an owner. Every process runs as some user, and the kernel checks identity on every operation. 3 types of users, 2 database files, 4 commands to know. Then we'll move to permissions in part 2. 3 types of Linux users. 1. Root user with UID 0, a super user, full control over everything. In most cases, you hardly log in directly as root. Use sudo instead. 2. Regular users. All regular users get a UID from 1000 and above. Each user gets his own home directory at /home/username and only access their own files by default. 3. System or service users. UID 1 through 999. These aren't people. They are accounts that services run. For example, Apache Web Server runs as the Apache user. MySQL runs as MySQL. SSHD runs as SSHD. They can't log in interactively. An analogy, think of an apartment building. Root is a building owner with master keys. Regular users add text with keys to their own flat. System users are the automated systems, elevator, water pump, generator. They work in the building, but they don't live there. The /etc/passwd file. Every user account on the system is stored here, one per line, with 7 fields separated by columns. Let's have a look through a sample entry in the /etc/passwd file on the slide. The first field has ec2-user, that is the username. The second field contains X. It is a placeholder for the password for the username, but the real hash for the password lives in /etc/shadow. The third field has 1000, and this is the user ID of this user. The next 1000 in the fourth field is the primary group ID. EC2 default user is the comment field. /home/ec2-user is the home directory. /bin/bash is the login shell that the user will use when they log into the system. Time for a quick demo. Let's look at the cat/etc/passwd file, right? So I'm going to go to cat on the passwd file. And we remember that it is a file where you have the entries, different fields that are separated by columns. So if I look at the very first entry here, I have the root, which represents the username root. There's an X here. As we have mentioned, it is just a placeholder for the password. The real hash value lives in /etc/shadow file. We'll see that later. The first 0 here is a user ID. So root has a user ID of 0. The next 0 here is the primary group ID, which is 0 as well. Then this root here is just a comment. And the comment for this root user has been just placed to be root as well. /root here is the home directory of the root user. And then we have here /bin/bash is the login shell that the root user uses when they log to the system. Let's look at the very last entry here, Ubuntu, right? We have Ubuntu here, another entry, Ubuntu, and if we notice, it also has an X. If you notice, all entries, second entries have an X, which again is just a placeholder for the password. 1000 here is the user ID. The next 1000 is the primary group ID. Ubuntu here is a comment, and then /home/Ubuntu is the home directory, and /bin/bash is the current login shell that the user uses when they log in, right? So that is how you should master reading the /etc/passwd file. Okay, back on our slides, let's move on. 2 more files are the LPR exam tests by name. /etc/shadow stores the encrypted password hashes, 1 line per user. The fields are also separated by columns: username, hash, last change date, minimum and maximum password age, and warning period, inactivity period, as well as expiring date. It's critical. Only the root can read this file. In all Unix, encrypted passwords sat in /etc/passwd, which everyone could read. An attacker could grab the hashes and brute force them offline. Modern Linux systems have moved the hashes to /etc/shadow and locked it down. Analogy: think of the /etc/shadow file as the locked safe at the back. Only the manager has the key. The next file that you should take note of is the /etc/skel directory. It's the skeleton or template directory, so to say. When useradd creates a new user, it copies everything from /etc/skel into the new user's home directory. That's how every user gets a default .bashrc.profile and .bash_locale files. Two more files that the LPR exam tests by name. The /etc/shadow stores the encrypted password hashes. One line per user. Fields are separated by columns: username, hash, last change date, minimum and maximum password age, warning period, inactive period, expiry. What's critical is that only root can read this file. In all Unix systems, encrypted passwords sat in /etc/passwd file, which everyone could read. An attacker could grab the hashes and force them offline. Modern Linux systems have moved hashes to the /etc/shadow file and locked it down. An analogy: /etc/shadow file is the locked safe at the bank. Only the manager has the key. The /etc/skel is the skeleton or template directory. When useradd creates a new user, it copies everything from /etc/skel into the new user's home directory. That's how every user gets a default .bashrc.profile and .bash_locale files. When you want every new user to receive a welcome message, you can create a file with the content and place it inside /etc/skel directory. Once the user logs in, the content of that file and the file itself will be copied to the user's home directory. In the LPR exam, know that hashes live in /etc/shadow, not etc/passwd, and that /etc/skel provides templates. Creating users. Useradd or adduser creates a Linux account. The entry is found in /etc/passwd. The home directory is copied from /etc/skel, the primary group, and the default shell as well. 2. Passwd sets or changes the password. Both require sudo. SU versus SU dash. This is where beginners always get very confused. Plain SU followed by a username switches to that user but keeps your current environment. Same working directory, same path, same exported variables. SU dash username does a full login switch, loots the target user's environment, moves to their home directory, runs their .bash hrc file. The dash makes the difference between a partial switch and a real login. SU with no username and a dash switches to root, but only works if you know the root password. Most cloud images disable this in favor of sudo, so there is no way you are going to be logging to the root account using SU dash on a Linux server that is hosted, say, in AWS. In the cloud context, EC2, you rarely create users by hand, but in a team environment, every developer gets their own account for accountability. You want the audit log to say Grace deleted that file, not EC2 user did something. Groups. Every user belongs to at least one group. The primary group is the user same name as a username by default. Files you create are owned by your primary group. Secondary groups. Additional groups you can be added to for shared access. Put all developers in a developers group so they can collaborate on project files. The /etc/group file stores a list of all groups. Time for a demo. We'll look at the commands on this slide and practice them. For now, let me go to the terminal and let's practice what we have covered so far. So I'm now on the terminal. And what we're going to do is we're going to cover user management. We're going to add a user as well as change configure a password for this user. So I'm going to show you how to create a user account interactively with the add user command, set a password, and then you understand the critical difference between SU, which is partial login, and SU-, which is full login shell. We'll add a user. It's normally the recommended way to do that on Ubuntu. It is free wrapper around useradd and creates a home directory immediately, as well as copies all the files that are in the /etc/skel directory, right? So let's get started. Let's go ahead and create a user. We need sudo in front, and then we have the command add user, and I'm going to say student1. If I hit enter, it's very interactive. It's going to ask me for the password. So I'm going to go ahead, type the password for this user, one that I will remember. Ask me to type the password. And if you notice, there is nothing appearing on the screen. That's very normal for Linux. Add user is very interactive. It's asking for the full name. I'm just going to hit enter and accept the defaults. And then right to the end, I will just type yes, all the information is correct, hit enter, and I've created the user. So the sudo add user student1 is very interactive. Now, I want to just create another user, but this time I want to use sudo user add instead, and you see the difference. This one, I'm just going to call it student5. Let me call it student5, right? Sudo user add student5. If I hit enter, it just complete. The user has been created, but I've not yet set the password. So we have created two users. I want us to verify, how do I know these users have been created? Where will I find them? I can go to the, remember we have, if I go to cat/etc/passwd, I want to see the bottom of the file. I'll say tail -5. And if I hit enter, I can see the last 5 entries. There's Ubuntu, which already exists. We already saw this user exists. Then there's student1, that's the user I just created. And then there's also student5, another user I created. And if you can notice, student1 has user ID 1001, student5 has user ID 1002. These numbers are assigned automatically by the system. So that is how to create a user. We can use either add user command or user add. I will encourage you to use more of the add user command for many reasons that you then have to go along, right? So that's, we have created a user and we have been able to as well see the verify that they have been created. But for user add student5, the next step now is how to set the password, right? So the first thing is I want to show you how to set the password for this user. There's the passwd command, and it also requires sudo in front. So I'm going to do sudo passwd, and then I mention student5 because password has not yet been set for that user. If I hit enter, have the possibility to set now the password for that user. And that's it. I've set the password. You just have to make sure that when you type the password, the first time and the second time, both of them should match. You're not going to see anything written on the screen, but if both of them match, you successfully set the password, right? So the passwd is used to set the password for a user. It can also be used to update the password for a user. So let's say I wanted to change the password, I can already do that. So take note that when you are using the adduser command, it also sets the password during creation. But when you use the useradd, you need to use the passwd command to set that. If you want to change an existing password, you can use as well the passwd command. So this is used to set the password. It can also be used to change an existing password. Right. So let's move on. And what we're going to do now is we are going to switch to student one. So let's first do a partial switch. So we're going to switch to the user using just SU, partial switch. How does that look like? SU student one. And if I hit enter, ask for the password that I have typed to make sure that it's correct. It switches, but if I do pwd, it says I'm in the directory /home/Ubuntu, right? If I do who am I, it says this is student one. Yeah. Now, notice something very important here. Student one, who am I confirms that it is student one that has login. But I'm still sitting inside /home/Ubuntu. The SU command without a dash only switches the user identity. It does not load students one's environment. And this is a trap that catches most beginners. So we have just done a partial switch where we have used just SU student one. And what we have realized is even though we are the user student one, we are still sitting in /home/Ubuntu, which is the home directory of the user Ubuntu. If this is not the way to log in fully or to switch fully, how should you do a full switch or a full login, right? So let me exit out of this because I'm student one now. I'll exit and I'm back as Ubuntu. And notice that here I was student one. I do exit and back as Ubuntu. To do a full switch, I do SU minus student one or SU dash student one. If I hit enter, you have to give the password. And if you notice, if I do a pwd, I notice it there /home/student one. I'm now in student one's home directory, which is what I should have. If I do who am I, it's obvious I'm student one, right? So if you look, using SU with a dash makes the difference. With SU minus, the shell performs a complete login. It will lose the student's home directory, the .bash rc files. It will set the home user correctly and puts you in the student's home directory. This is what you want 99% of the time. So always use SU dash or SU minus username, unless you have a specific reason not to use the dash. Right? So when you are switching, make sure you use SU minus always. This one is always a partial switch, and it's not most of the time what you are looking for. The next thing is we are in student one directory. Let's look at, I mentioned that there are some files that are present in /etc/skel, and these files are always copied to every new user home directory. So if I do ls minus la and hit enter, I notice that some files are already present in the /home/student1 directory. The .profile, hidden files, .bash rc, .bash_lockout, and even the .bash_history. So these files are coming from the /etc/skel directory, which is like a template that for every user that is added, all these files are automatically copied to that directory, right? We're going to create groups, add users to them, and demonstrate the -a flag danger live. We'll grant sudo admin access and clean up properly with deal user as well. So let's create 2 test users once more, right? Remember that I deleted the student1 user, so let's verify in our /etc/passwd file to show that the user was actually removed. So I'm going to start with less, or I can use the command we're practicing. I'm going to grab student1 from /etc/passwd file, and I should get an empty answer. This means this pattern does not exist in that file. I can still go as well and do a tail -n minus say 5 of the file /etc/passwd. If I look at the tail of that file, I'll notice that student1 is deleted. I only have student5. If you remember earlier on, when we created student1, right? Student1 was present here when we did add that user student1. I did a cut of that passing to tail -5, and we could find student1. But after removing student1, no longer belongs to that file. So let's go ahead and add that user back again. We're going to create 2 users. So I'm going to do sudo add user student1 again. I'm going to give the password for that user. I have to repeat. Okay, that was correct. I'm just going to accept the defaults. And it's all yes. So the user must have expleted. Let me add another user. I'm going to call this user student2. Again, it's going to ask me for the password as well. We should be profits in creating users, finish this lab and practicing them, right? I'm also going to accept the defaults. And if I go ahead and check and do tail -5 on /etc and do passwd, I should see that I have 2 new users, student1 now, taking 1001, and the student2 1003. Those are the new users that I've just created. So we need these users for this demo so we can demonstrate the group membership danger, right? We'll run add user for each one, set a password, and then press through the entire files to move on. Now, let's create a group and verify that they exist. How do I create a group? I'm going to do sudo groupadd. It's a very nice name or nice command. But the group is groupadd as well. I'm going to call this the web team, right? Now, where will I find the groups? I have to look inside. Let's do tail -5 -5. If you want to look the groups that you have in your system, you check the /etc/group file. If I hit enter, you notice that there's a group called web team. Remember that by default, when you create a user, a primary group with the identical name of that user is also created. So student1, student2, these are all groups that belong to new users that were created, right? So we have a web team here. That's the group I've just created. There's a group ID 1004. Now, I'm going to add student1 to web team safely. And how do you do that? I'm going to do that with the -ag option. So To modify and add a user to a group, I use the usermod command, which is user modify. I'm modifying the group membership. At the moment, the student, like we can do that, student one, right? So if I were to do ID student one, right, I have to surely have to use sudo. Let's see. Yeah, ID student one, it shows that it belongs only to a group called student one, because when you create the user student one, it automatically also gets a group, a primary group with the name student one. So the only groups that student one belong to are student one, and as well into a group called users. That's all. But I want to add student one to the group web team. How do I do that? I use the user. I'm going to do sudo user modify, just user mod. And then I have to use the -A and G options. Take note, I'm using -A and G option. I'm adding the students to the web team group. And what's the name of the user student one? So I'm using this command. The command is having these options. This is the name of the group I want to add the user student one. If I hit enter, right? And now if I do ID student one, what happens? It shows that student one, the groups it belongs to student one as well as the web team. Notice this was not the case. So student one now belong to two groups, right? You can also do groups. You see student one. That will also list the different groups that student one belong to. So student one now belongs to two groups. Their primary group, also called student one, and web team as a secondary group. This is how shared access works with Linux. The web team group can now be given permissions on shared directories, and student one inherits those permissions automatically. Now, I'm going to show the danger of running user mode without the -A option. Let's look at student two. If I do groups, student two belongs to, the user belongs to the group student as well as users, right? Even if I do ID student two, you still see the same output. So student two belong to the group student two and users. Now, let's say I want to add that user to the web team, and then I do use sudo user mod, and I use -G without the A. Take note here, I didn't use the A. Here, I'm not using A. And if I go ahead and I just say web team student two, what will happen? Okay. It happens in a command the user mod is not correct. So if I complete that and I do now ID student two, oops, student two. So based on this output, the group 100, which is the users group, has been completely removed. I only have now but the primary group and the web team group that I was adding. So normally, when you are using, when you are modifying any users group, make sure that you use the -A option. Always use the -A option. This is very important, right? Now, let's look into, I'm going to clear here. Again, let's look into how do you grant a user admin privileges such that the user can be able to run commands with admin privileges. That is something we did talk about early on, right? So if I want that student one, for example, to have admin privileges, how am I going to do that? So let's get into that. So if I want that student 1 to get admin privileges, since I'm using Ubuntu, and if you remember, ID here shows that there's a group called sudo here. All I need to do is to make sure that student 1 joins the sudo group. But before I go there, let's do a quick demo to understand what we are about to do, right? So if I were to check the groups that student 1 belongs to, right? So if I do ID student 1, I see that student 1 only belongs to the group student 1, 100, and does not belong to the sudo group. So for example, if we were to switch to student 1 fully with su dash, and I say if I were to go to student 1 and I hit enter, I'll need to type the password. And if I were to try to run the command that requires privileges like adduser, say I was trying to create a user student 7 and I hit enter, I'm still student 1. I'm afraid I can't do that because student 1 does not have permissions to run the sudo command. Now, we want that student 1 should be able to gain these admin privileges. So I'm going to exit from here, and I'm going to go ahead and add student 1 to the sudo group. And I do that by doing sudo usermod, and I will do it by using -A and G option, capital G. The name of the group is sudo student 1. And if I do now ID student 1, I notice that student 1 now belongs to the sudo group, just like Ubuntu. Ubuntu also belongs to the sudo group. So if I were to switch to student 1, and I'll type the password again. Now that student 1 is now a member of sudo group, let's try to add the user that we tried adding last time and it didn't work. So sudo add user, we want to add student 7, right? We tried and it failed. So if I hit enter, what happens? It asks me to give the password for student 7. And I give that password. So this password is for student 7, right? It asks for the details of student 7. I'm not going to give, I'll just accept the defaults by hitting enter. Just hit enter right to the end, and that's complete. Now I can check if student 7 has been created by doing a grep of student 7 on the etc/passwd file, and I should see an entry. Now I see there's an entry for student 7. That means that user has been created. So that is how you can configure student 1 to become an admin by putting that user into the sudo group, and the sudo command that we tried and it failed now works, right? So it's very easy to configure a user to be able to act as an admin, borrow root privileges. Now with that complete, we go ahead and delete student 7. Again, how do I do that? I'm just trying to clean up. Sudo deal user, and I'll use the -- remove home. I want that the student 7 home directory is also removed. So sudo deal user -- remove -home, and I'm doing that for student 7, right? If I hit enter, that completes successfully. If I try to look for that user inside the /etc/passwd file, there will be no entry. So that user is no longer present. All right. So that is how you can make a user student 1 here become get administrative privileges and will be able to use the sudo command. All right, let's move back to our slides and continue.